All right, let's dive in. Today, we're going to master a core skill in trigonometry, and I mean it. By the end of this, you'll be able to look at pretty much any right triangle and find a missing side, even if you only know one other side and an angle. So, let's get to it.
So picture this. You're standing there looking up at this giant skyscraper. You know exactly how far away you are from its base. So how in the world do you figure out how tall it is without, climbing it? Suddenly, your trusty math tools, they just don't cut it.
I mean, we all love the Pythagorean theorem, right? But here's the catch. It needs you to know two sides to find the third. And in our skyscraper problem, we've only got one. This is where trigonometry and our good old friend SOHCAHTOA Toa steps in to save the day.
And look, this isn't just some abstract tool for your math class. It's really an algebraic superpower. It's the language we use to measure and make sense of the world around us, from that building right in front of you to the farthest stars in the sky.
So here's the secret sauce. Every single one of those SOHCAHTOA equations connects exactly three pieces of information, one angle and two sides. That's the magic number. And it's a guarantee. If you know any two of those three things, a little bit of algebra will always let you find the third, every single time. Okay, so how does this actually work in practice? Well, it turns out there are really only two algebraic situations you're ever going to face when you're doing this. So let's break them both down step by step.
First up, we've got the easier case. This is what happens when your unknown side, your x, ends up on top of the fraction, in the numerator.
Okay, let's walk through this one together. Step 1, choose your function. Looking at our angle, we have the adjacent side, which is 12. We want the opposite side, x. So, opposite and adjacent, that's TOA, which means we use tangent. Step 2, build the equation. Tan of 35 degrees equals opposite over adjacent, so tan of 35 degrees equals x divided by 12. And step 3, get x by itself. This is the easy part. You just multiply both sides by 12. A nice, clean, one-step solution.
All right, now for the fun part. You punch 12 times the tangent of 35 into your calculator, and what do you get? 8.40. Just like that, you found the missing side.
But what if x isn't on top? What happens when it's trapped down there in the denominator? Kind of like it's in the basement of the fraction. Well, that's our second scenario. It looks a little scarier, but there's an awesome shortcut.
Let's take a look. Here we have the opposite side, 75 feet, and we want the hypotenuse, x. Opposite and hypotenuse, that's SOH, so we use sine. We set it up, sine of 50 degrees equals 75 divided by x. Now here's the trick. Instead of doing a bunch of algebraic steps, you can just swap them. The x and the sine of 50 degrees literally trade places. It's a quick, mathematically solid move that saves a ton of time.
So you just typed 75 divided by the sine of 50 into your calculator, and there's your answer. The support beam has to be 97.91 feet long. See? The process works perfectly, even when that variable starts out in the trickier spot.
Now, before we wrap up, I have to share what is probably the most critical tip of all. Seriously, this is the one thing that trips up more students than anything else, and I want to make sure it doesn't happen to you. And I'm not exaggerating. This one tiny mistake can single-handedly destroy an otherwise flawless test. And the worst part is, it has nothing to do with whether you understand the trig, it's all about your calculator. So here's what you're going to do. From now on, before you start any homework, any test, you run this little litmus test. Type in sine of 30. If your calculator says 0.5, you're in degrees mode. You're safe. You're good to go. But if you get some crazy number, like negative 0.988, stop. You're in radian mode. Find that mode button and switch it to degrees immediately.
So why did we spend all this time on triangles? What's the real payoff here? It's because mastering this one little skill takes you from just solving problems on a piece of paper to literally being able to measure the universe.
Well, check this out. There's this incredible method called stellar parallax. It's how astronomers figure out how far away stars are. They measure the angle to a star, then they wait 6 months for Earth to get to the other side of the sun, and they measure the angle again. What they've done is create a gigantic triangle out in space.
And this is where the scale just becomes mind-boggling. You know that adjacent side of the triangle we just practiced with? In this case, it's the distance from the Earth to the Sun, 93 million miles. And by using the exact same SOHCAHTOA algebra we just went through, they can calculate the distance to a star that is light years away.
So think about that. The algebra isn't just a classroom exercise, it's a fundamental key that unlocks measurement on a cosmic scale. If this simple math can find the distance to stars, what could you measure with it?